Okay, now let's go through the question 3. The following diagram shows a busy highway intersection which is 15 meters wide. An empty bus of length 8 meters is traveling along the intersection at a steady speed of this one. Okay, so steady speed means what? Steady speed means constant speed or constant velocity. Okay, steady speed means that. Okay, so we have a bus. The bus is 8 meters long. And question A, how long does the bus take to completely clear the intersection? So the bus is here, and then the bus is go through here. So from here, travel to here, that will be how long? Don't forget we got 8 meters here. So the total distance of the bus need to travel will be 8 meters plus 15, which will be 23 meters. And how long does the bus? Now is for the time. Okay, we know time. So this is constant speed. So time equals to distance over speed. Okay, and the distance is 23. The steady speed is 28. Okay, so from the calculator we can know this will be 0.82. So the answer is 0.82 meters. Okay, so I think the important thing from this question is after you read the question, you need to know the situation, and this is a constant velocity situation. There's no acceleration involved. The next one, the empty bus still traveling at a steady speed of 28. Okay, still steady speed of 28. And the drivers see a dog on a road a distance 100 meters away. And the bus requires minimum 70 meters to come to a complete stop from the point at which the driver applies the brake. Okay, so this sentence is basically a condition. Okay, so you take it as a condition. So you saw it a minimum stopping distance after we have a brake. Okay, and then the bus driver has a reaction time of this one before it applies the brakes. Now question B, calculate the distance of the bus travels before the driver applies the brake. Okay, before the driver applies the brake, so what will happen? There's no brake, so there's no force. Okay, so this again is a constant speed. Am I right? Constant speed questions, and the distance will be speed times time. And what will be the speed or velocity, which is 28? And it takes the bus 0.8 seconds, so this will be our time. And then you see your calculator, so this will be 22.4. Okay, so the answer is 22.4 meter. So this is a constant velocity question, so don't overthink it. Now we want you use the kinematic equation to find the acceleration of the bus. So this means we have the brake. After we take the brake, there's some friction involved, and we want to know the acceleration. So what do we know from the question? We know the question initial speed is 28, and they want to stop. Okay, so final speed will be 0, and it takes for how long? We know the distance, 70 meters. Okay, and we want to know the acceleration. Okay, and after we read this one, we found something. We found that we don't know time. Am I right? We don't have time. Okay, so what formula are we going to use? Vf squared equals to Vi squared plus 2AD. Okay, and now we can put the number in. Vf is 0 and Vi is 28 squared plus 2 times A times D. D is 70. Okay, and now we rearrange the formula. So A is here. So we need to keep this item, and we need to conventionally we put the unknown in this way. So 2 times A times 70 is here, and we are going to shift 28 square to the other side, which becomes negative 28 square. And now we want to find the A. So A will be how much? Again, A will be negative 28 square and divided by 2 times 70. Okay, and use your calculator to get the answer will be negative 5.6. Okay, so our acceleration will be negative 5.6 meter per second. And what does the negative mean? The negative means is slowing down, is the acceleration, am I right? Opposite to the speed. So this is slowing down. So which is reasonable. Okay, only few of you write a negative. Most of you didn't write a negative, but keep this one is quite good. Okay, because you know acceleration is a vector, and we can have the positive and negative to show the direction. Okay, now the next question, D. What is the time taken for the bus to stop from the point of the driver's applies the brake? Okay, so now we want to know the time. And again, what do we know now? So we know the initial speed is 28, final speed is 0. Okay, and you can use distance for 70, but now we know the acceleration is negative 5.6, and we want to know time. Formula can we use? We can use the final speed equals to VI plus AT, and we put a number in. VF is 0, VI is 28, plus A is how much? Negative 5.6 times time. And you rearrange the formula. T equals to, you shift or you move 28 to here, and it becomes negative 28. And you divide it by what? Negative 5.6. Negative divided by negative is positive. So the answer is 5. Okay, so it takes for how long? 5 seconds. The driver now accelerates the bus from rest, okay, by changing gears twice. Okay, so again, from rest, VI equals to 0, and they change gear twice. So changing gear is a condition. And during each gear change, the bus at a constant speed. Okay, so gear change, the bus is in constant speed. Each gear change takes 2 seconds. Okay, so this is another condition. Okay, so on this occasion, the bus A accelerates uniformly from rest for 6 seconds, and the change gear at reaching speed at 4. Okay, so we know this is acceleration uniformly for 6 seconds, and then speed will be, final speed is 4, and then they change gear, first gear change, and that is a constant speed for 2 seconds. For B, okay, that was B, and then the bus accelerate at the same rate as A, so they have the same acceleration. Okay, same acceleration to this one for the next 9 seconds. Okay, and the bus change gear again. The bus change gear to become constant speed. Okay, so now we need to know what? We need to know the acceleration here first. Acceleration for the stage A is delta V over delta T, am I right? From the rest to 4. So 4 minus 0, okay, and take 2 seconds. So the acceleration is 4 over 6, 2 over 3. So this will be our acceleration. Okay, we'll see how we can use this one later. Okay, now we need to do the VT diagram, velocity time graph from A to D. Okay, so we have some planning. So I have 6 seconds for A, and then 2 seconds gear change, and then for the next 9 seconds. Okay, and then we have another gear change for 2 seconds. Okay, so in total time, how long does it take? So 8, 10 will be 19 seconds. So if we start from here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this will be our time for 20 seconds, 19 seconds, to cover 19 seconds. Okay, and then the speed will be how fast. Okay, so the first one, the first stage, they travel to 4. Okay, so stage A, final speed is 4. And from there, same acceleration. So we need to see C. The final speed is how much? The final speed, V is AT, am I right? Okay, or we can say VF equals VI plus AT. Okay, so stage 1, they travel to 4. And acceleration is 2/3. And they travel 9 seconds. Okay, so before plus 3, 9 cancel to become 3. 2 times 3 is 6. So the second stage speed will be 10. Okay, so let's have a look. 1, 2, 3, 4. This is 5, 6, 7, 8, 9, and this is 10. Okay, the final speed will be 10. Okay, so now we can do the picture now. Okay, for the first 4 seconds is here, and the speed will be 4, so it will be here. So this is accelerate, and then later they change gears. So this is A and this is B. Okay, and then another 9 seconds from 9. Oh, sorry, I made a mistake. Okay, one more time. Okay, stage A, they use 6 seconds travel to 4. So 6 is here. 6 seconds they travel to 4. So this is stage A. And then use 2 seconds, 6, 7, 8 to here, 2 seconds. This is B. Okay, and then they use the same speed. They travel to 10 from 8, and 9 seconds will be 17, 16, 17 is here. So 17 to 10 is here. Okay, same acceleration rate, so the gradient will be the same. And then they change gears again, D will be there. Okay, so if we use ruler, okay, and we can have our diagram. I make it slightly thicker, it's more easier to see. So so this is A. Okay, and this is B. And then this is B. And this is C. And this is D. Okay, so we have stage A, stage B, stage C, and stage D. Okay, and to make it more specifically, we know at this point it will be 6 and 4, and at this point it will be 17 and 10. Okay, so this is our VT diagram, and don't forget the label for the axis. Here's V, meter per second. Here's T, unit is time. Unit is seconds. Okay, so now they want you find the total distance covered by the bus in section A and B. Okay, so in section A, I think it's easy. So section A, DA. Okay, many ways to do it. Okay, for example, because we have the VT diagram, okay, so we can use triangle. Am I right? For here. So this is the triangle areas. The time, the base is 6, and the height is how far? The height is 4. So 6 times 4 is 24, divided by 2 is 12. Okay, so distance A is 12 meters. Okay, and distance B is how big? Okay, so here is B is a rectangle. Okay, so it is width times length. So this is 2, and this is here is how far? Is 4. So the travel is 8 meters. Okay, so the total distance will be how far? The total distance D will be DA plus DB, which will be 12 plus 8 is 20. Okay, so that will be 20 meters. If you don't like to use the diagram, you can also use the formulas. For example, we can do equation. DA will be how much? DA will be half VI plus VF. VI plus VF times T, and which will be half. VI is 0 and VF is 4, and time is 6 seconds. And again, this will get you the same answer, 12 meters. Okay, and dB is constant speed, so I think even you don't use the diagram, you can use distance equals to speed times time, and speed is 4 and time is 2, so 8 meters. They have the same answer. So 12 plus 8 is 20 meters. Okay, the last one. What is the acceleration during the bus in section A, and which we just did previously? Acceleration, and you can use the definition. A equals to delta V over delta T. Okay, put the number in. Delta V from 0 to 4. 4 minus 0. Time is 6 seconds, so it's 4 divided by 6. 4 divided by 6, so that will be 0.67. Okay, so it's 0.66666. Okay, I'll round it to 0.67. Okay, so answer is 0.67 meter per second. Or you can say, I don't like it, or you say, oh, I like to use the formula. The formula being given, what would be the formula given is VF equals to VI plus AT. Okay, and then you can use final speed is how much? Final speed is 4, initial speed is 0, and A we don't know, and T is for how long? T, sorry, so initial speed plus acceleration you don't know, and T is 6 seconds. And again, if you rearrange the formula, A becomes what? A becomes, here's times, and when you shift to the other side, it becomes divided by, and here's 4. Again, it's 4 divided by 6. Okay, so again, this will be 0.67. Okay, so same thing. No matter what method that you are going to use, you will have the same answer. Okay, and hope this is clear.